Again, without getting into too much of the math, you can inspect the results here by getting the eigenvalues. Again, not getting into the math. You can do some more of your own homework on the math behind there. And then, of course, you can visualize those eigenvalues as well and look at how the variables line up on an XY axis or PCA plot. So let's run this real quick. Doesn't take long because I've already subsetted the number of attributes. It displays the PCA results of the first two dimensions. That's important. The first two dimensions, we have an X and a Y axis, right? So if you count up the percentages between the two dimensions, we have 30% here and 20% here. So between the two of them, if I just add those up, I have 50% of the variability is represented in these first two dimensions. So essentially, the other 50% of information contained across the other attributes is lost. So I'm not incredibly happy with that amount of loss across the first two dimensions. So you'll have to think about how you want to interpret and use that information for the next step in your analysis, which may be going to the clustering. Next, using the first two dimensions, right? As I mentioned, you can look at the eigenvalues and just list them out like this. You can see the first two dimensions account for about 51%. And as I go down, dimension 3, if I add the third dimension, it adds another 15% of the variability within that data. And then it just goes up from there. Remember, I have 8 initial attributes. So if I use PCA and I still use 8 dimensions, of course, all of those dimensions are going to add up to 100%. That just makes logical sense. Typically, what many people will do is look at an eigenvalue of greater than 1 to choose which dimensions to keep. So in this case, I might keep the first 3 dimensions as using those 3 dimensions for the attributes in the next step of the analysis. So I'm going to display this. This is actually a scree plot. It actually shows how much of the dimensions contribute to the overall variability of the data. And of course, I can run this again as well, just showing how the variables line up across the dimensions. Next up, I can actually look to see how the variables or which variables contribute the most to each dimension. That'll be important just to see which variables are going to be associated with these new dimensions or these new principal components. I can do that by using a correlation plot. I've loaded up my core plot package. Make sure that's installed and available to you in your packages list. Okay, you can just click install core plot. Make sure that's in there. It's already installed, of course. And then I can just call this function called core plot and then pass the squared cosine results from this object right into as the first argument or parameter in the function, and make sure you do is.core equals false, and I can just run that. And this shows that MPT4 private, percent Pell and percent federal loan are highly rate pretty high on dimension 1. And then for dimension 2, we have the highest being admissions rate and undergraduate degree seeking white students. And finally, pub is a little bit less correlated with dimension 2. Finally, you can see the same thing on dimension 3 and dimension 4. Now, what would I do next with these results? I'd actually take the first 2 or 3 dimensions and pass those dimensions to my clustering algorithm.